everyone. Welcome to CXO Spice Talk. In this episode, we will talk with an expert to better understand what's behind a ship without a crew and what it means for the rest of us on shore. I'm delighted to host a very special guest today, Tony Davis. Tony is the program executive for Navy and Marine Corps at IBM. So welcome to Spice Talk, Tony. I'd love to have you introduce yourself to the audience.
Absolutely. It's a pleasure and honor to be here. Thank you very much, Helen, for this opportunity to share some stories and some insights. So my background, I've been with IBM for almost 20 years. Been a long time of working in consulting and technology and in innovation in many aspects of IT and strategy, and really then recently AI and machine learning, and then Mayflower as well. So what I've had the pleasure to do is really look at some of the most leading edge research development efforts and how do we bring this into the clients that we service in federal and commercial. I specialize in the federal defense market. My background as well, I'm a naval officer as well, 27 years in U.S. Navy, surface warfare and intelligence. So I've had a lot of operational experience seeing how the Defense Department sort of leverages technology and implements it to help national security objectives. And then working with IBM, you get to see the embryonic stages of the technology as it's engineered, as it's architected, and as it's deployed in client environments. So you get to see both sides of that equation. And that's been sort of my sort of story. And I've had a great time at IBM, a 20-year career. Continue to learn new things and meet amazing people and partner up with great team partners across the industry. So it's been a fun journey.
Well, it's such an honor to have you here, Tony. That's a recap from our last CXO Spice Talk. We got to meet the Mayflower autonomous ship, a completely unmanned maritime climate research vessel, otherwise known as MAS 400. So IBM actually architected the AI technology, hybrid cloud strategy, and edge computing powering the Mayflower autonomous ship. I had the pleasure speaking with Brett, who is the founder of Premier yesterday. So he actually shared the backstory of how this whole idea or concept of MAS came about. So could you share with the audience, how did IBM decide to come to the table for this initiative?
Absolutely. IBM, one of the hallmarks of IBM is we love a grand challenge. IBM has never shied away from solving some of the world's toughest problems, whether it be supporting Apollo mission and putting man on the moon. We're always looking for something that can really push the envelope of innovation and breakthrough technology. So we were at a conference. I wasn't there personally, but some of our colleagues that were in the UK and France attended one of the conferences that Brett was at. They heard about his grand vision, his grand challenge. How do we basically replicate the Mayflower journey, but not looking backwards 400 years, look forward 400 years and bring in the innovation to help bring the art of possibility and explore the ocean, which is one of our most cherished and prized sort of assets. And he needed a technology partner that had reputation to deliver and to really bring innovation in a way that had never been done before, which is an fully autonomous ship. So we kind of heard his vision. We had a lot of experience implementing AI across multiple industries, whether it be financial banking services. We've had a lot of experience using these tools that are on Mayflower. So we had the credentials to implement and to configure it. And so one of the things you realize when you're in the ocean is very unforgiving. The stakes are so high, you don't have the chance to fix something once it breaks in the middle of the ocean when you're a fully autonomous ship, no crew on board. So he wanted to make sure that the technology was very reassured and was reliable enough to withstand a harsh environment. And that's a reason why he came to IBM.
That's awesome. I know Brad was very thankful for IBM's partnership. He bragged about this journey with IBM. So speaking of that, we can talk about the space exploration, right? It had many implications on everyday life and new products, new technology, new ways of thinking. So what is the connection between a crewless ship, cruising the ocean and the world we live and work in. Tell us why this is important to all of us and the role of IBM playing in that role, in that.
Absolutely. Obviously, the ocean covers 3/4 of the earth. That resource in and of itself is so vitally important because 50% of our air is created from the ocean. Our resources, transportation, it is from the ocean from which we have an economy to transport, share goods and services. So what's so ironic is that we don't understand the ocean very well. We actually know more about the moon than we do about our own oceans. So that's one of the areas where exploration was calling. But that's a grand challenge because the ocean is so large. And to have a crewed vessel with persons and boats out to sea is very costly. I personally, like I said, as a naval officer, been around, sailed, I was a navigator on board Navy ships. It's very, very dangerous, very boring, and very laborious. And to have a crewed vessel out there is very costly too. So what Brett's vision was to say, well, can we explore the ocean in a way using robotics, using automation, using fully autonomous vessels, which is one of the great frontiers of exploration. So we said, absolutely, we could do that. We have the tech. We just need to come together with some creative solutioning, envisioning, and build a platform that basically sort of replicates what a crewed captain-driven ship can do.
Mm-hmm.
And so that is part of the vision that we believe by developing autonomous vessels to patrol the oceans, we can monitor, sense, measure the health of the ocean and therefore the health of the earth. If the oceans are healthy, the earth would be healthy, and us as humans, we get to live here in harmony. If the oceans continue to suffer, as we're seeing signs of higher sea temperatures, rising sea levels, coastal erosions, and we're not doing anything to address it, we might be in a world of catastrophic environmental changes, and so we need to start to measure how the earth is doing via the oceans.
It's fascinating to see the power of technology, right? And speaking of that, what type of other use cases can we see with the technology on board the MAS 400, particularly in the areas of remote work where latency could be a big issue?
So, absolutely. The use cases are just, we're learning every month, we're learning about a new potential use cases in multiple industries. Also, the maritime industry, as a lot of us are familiar with what's happening with the supply chain and the lack of qualified mariners to transport goods and services across the ocean. I mean, 80% of our commerce is across the oceans. Mm-hmm. And there's not enough qualified mariners to operate these ships. And they're very, very costly. So one of the major use cases, and we're talking to some large shipping companies, they're absolutely interested in leveraging Mayflower technology to augment their crews, is to basically allow an AI captain like Mayflower to basically navigate the ships and have a very minimal crew. Minimal, we're talking very few number of personnel on board, if that, to augment the capacity to deliver these resources in a much more cost-effective, environmentally conscious way, versus having those big super tankers which consume a lot of fossil fuels and a lot of resources. And that kind of work is actually very laborious and sort of boring. Mm-hmm. My brother is a master merchant marine, and 80% of his work is pretty much sitting there waiting for something to happen as he transits the oceans. Well, let the AI systems and robotics manage those. Just like we actually have an aircraft and a lot of commercial airplanes, majority of the flight is all instrumented, all automatic, 80%. Mm-hmm. Pilots really don't do a lot when they're flying an aircraft, except when they land and take off. We see the same vision for the maritime industry. Obviously, research is also a prime example of a use case. In order to research and collect data, you've got to have presence. And there's a lot of ocean to survey. If you use a robotic system, autonomous system like Mayflower, it can stay out there for years without needing to get refueled, mm-hmm. without the need to come back to shore. The devices for latency is born because all the computing is on board the Mayflower. Every sensor is connected through edge device management application. There's an IBM technology we've used in the space station, we've used in the financial industry and manufacturing and production lines to monitor performance on the floor, to monitor operations as they unfold in real time. So we can do the same thing on the Mayflower because all the sensors are tied together and they're processing on site. So data does not have to fly through the satellite back to a server, a shore-based server. It can be processed and adjudicated on the vessel itself. So we don't have to have a connection with a satellite or anything about cloud services. It can process everything on site. Now, we do like to have updates as it discovers new scenarios where it's not familiar with. We can push new code and AI models to the platform once we have a connection, or push data back to the headquarters to process it for further analysis. So it's sort of a hybrid model. And so therefore, we don't require it to be tethered to a cloud server. It can operate autonomously. That's why we call it a fully autonomous vessel.
That's amazing, right, to hear. So I'm glad to see the work has been done in collaboration with Premier and other, partners in the ecosystem. One thing on top of mind, right, we know the temperature of the Earth is rising. In January 2021, the average global land and ocean temperature was 7th highest since records began in 1880. What kind of marine research does MAS 400 do to explore climate change?
Sure. So part of the whole impetus for the Mayflower was to perform research. That was its initial vision, and it's still going to be executed as such. There are scientific payloads incorporated onto the Mayflower. Scientific payloads are sensor packages, computing packages that are fit for the mission that we're going to deploy Mayflower to support on its transatlantic voyage this spring. So some of those payloads look for temperature of the sea. The temperature is important because we want to make sure, is there truly a heating of the sea temperature in the middle Atlantic as opposed to the coastal regions? Is the temperatures consistent across? We'll be measuring that in real time. The salinity. Is the salinity factor rising? Is it rising faster than we expect or anticipate? We don't have measurements that can characterize or explain the factor of the trajectory of salinity in the ocean today. pH levels. There's a pH sensor on board Mayflower. We're concerned about the acidification of the ocean. If the oceans are getting too acidic, well, fish and mammals will not survive. And that's a problem. That's toxifying the ocean by pollutions that are added, plastics and oil and debris and things that really start to change the chemistry of the oceans. We want to know and map and chart the trend lines. And that's all sort of scientific payloads that are incorporated into the Mayflower today. We even have we call it a digital tongue. It actually will sample for plastics. Use a very sophisticated AI model that will look at electromagnetic pulses to sense certain pollutants in the water. And that's all trained through our IBM research arm. It's a sensor tongue that's been incorporated in the Mayflower hull, and it will just detect plastics, certain type of chemicals in the water. We can detect that, and that can be reported back or processed on the vessel as it goes through across the Atlantic or Pacific or whatever missions it will be going to. We also have other measurements of wave energy, accelerometers, obviously, and visual AI camera that will look at wave heights and calculate the energy of the ocean hitting the coastlines. And that could be another method for an early warning detection for oil rigs or ocean vessels that are out there. Normally buoys do this, but a Mayflower can do it more dynamically. If there's a forecasted storm coming, we can actually anticipate what it might do further down when it hits shore. A lot of these scientific payloads are already incorporated, operationalized, and they're in use today in various industries. We just brought it together to bring it to Mayflower to make it more research grade and ready to operate.
That's amazing, right? I can imagine, I can only imagine, what you can do as long as you not only being innovative, but also you can come up with research, allow people to act on that innovation, right? That's really critical. So let's talk about another topic on many people's mind these days, supply chain, right? How will MAS technology improve efficiency and related autonomous vehicles?
Absolutely. So actually, one of the bottlenecks in the supply chain, it may not just be, the point-to-point destination from, geographies across the Pacific or Atlantic. It can also be inside the inner water lanes of the United States, the rivers. There's a lot of barges. There's a lot of, taxis that basically transport materials, supplies, goods, and services across the Mississippi, for example, or other waterways around the world. And those are a perfect use case for what an autonomous vessel can do. It's sort of like a robotic taxi that ships goods and services point to point, because those transits are not that difficult. Those vessels pretty much stay in their lanes because they know the routes. And that's a perfect example of how an autonomous vessel like a Mayflower AI captain could implement and alleviate a lot of the sort of, once again, staffing challenges. If you don't have to worry about having qualified mariners doing very small transports of goods and services, you let the machines and the AI systems do that. It frees up these mariners to do more critical jobs versus a mundane, transit across a river to send fuel supplies to the other side of the river. Same thing could be applied for a transatlantic, trans-Pacific, transports of goods and services as well. Like I said earlier, it can help alleviate I call it a cognitive burden. Mariners get fatigued when they're out to sea for weeks or months. And so a lot of times there's mistakes that are made. I've been there, I've been guilty, I had fatigue and I wasn't on my A game and the sharpest person. I oversaw something and had a close encounter with another vessel. These accidents do happen out there, but having an AI captain assisting can help alleviate sort of the mistakes that humans tend to make when they're fatigued or when they're bored or not paying attention. Machines don't deviate from what it's taught.
Mm-hmm. Mm-hmm.
It's rule-based.
Or you can tag team, right, with the AI captain. So that sounds like a perfect way of being augmented by AI rather than being replaced.
Absolutely. We don't, in our view, in IBM's position, we don't really see AI as replacing the human. AI does really well in repetitive tasks, very defined, very specific repetitive tasks. That's a great way to augment and free up the human mind and the cognitive burden so they can focus on higher value activities.
Absolutely.
Versus the mundane.
Absolutely. As a matter of fact, many prestigious organizations are interested in this Mayflower autonomous ship, including the Navy and NASA. What kind of feedback or conversations are they having or are they giving so far?
That's a great point. Obviously I have a lot of information I work a lot with Navy customers across the defense and research space. Obviously the Navy has a lot of ships. And a lot of the responsibility is really safeguarding the safe navigation of these seas. As the defense industry is really there to provide national security, and it's really to protect freedom of shipping, freedom of lanes, to make sure that commerce continues to thrive and is not abated. And really as a deterrent. I mean, it's a strategic deterrent. That's why there's vessels and we have trade embargoes, we have United Nations sanctions, and unfortunately the United States Navy has a lot of that mission, but it's a very taxing mission for the crew and is a very expensive mission to maintain. But I think the Navy is really interested in perhaps using a Mayflower technology platform to patrol for compliant fishing, for example, or illegal smuggling of illegal weapons or contrabands or trafficking in persons. They would like to use this kind of technology to monitor the sea lanes to make sure that there is no illicit activity going on where it should not be. And also the Coast Guard has a really important mission, right? They got to maintain the integrity of the coastal regions, safe boating, Even the recreational or compliant boating. They got to make sure that people are not fishing in illegal or controlled areas. So maintaining compliance with the coastal policies and regulations are important. And it's a very taxing process if you're having sailors do that day in, day out, when you can have systems like Mayflower perform those missions 24/7, 7 days a week without taking a break, and then just tipping off the various agencies when there is a problem, which then requires intervention. NASA, obviously you mentioned about NASA. Well, obviously NASA's absolutely interested, and they're using some of the IBM technology on the International Space Station today as we speak, on some of the edge application management devices, which are sensing the exterior of the space station for any debris, particles. Like I said, it's not easy for a space astronaut to walk out there and do a external assessment of the conditions. These devices are monitoring 24/7 and providing updates. So if there is a serious issue, they can then make a risk decision whether to send an astronaut out into space to investigate something. So the edge application systems and AI systems are being used today. Other things that the NASA has been interested in using is, can we use a Mayflower type capability for a Mars mission, robotics? And it's a classic use case because you basically are training the rover to basically sense, think, rationalize. And that's what Mayflower does today. It has all the sensors, it has the ML AI training. And if there is unknown areas or circumstances, we can push updates based on what we see, based on limitations of our knowledge of the environment. And that's where that dynamic communications through edge application allows that. So that's another sort of area that NASA is showing interest in.
That's amazing. Those are great stories that resonate with me dearly, right? So thank you for sharing that. I know you spoke with Gartner Edge research analyst Bob Gill recently, and what did really Gill have to say about MAS technology reimagining the shipping industry?
He was very fascinated with the fact that if you could basically augment the shipping industry with an AI captain, it would lower the cost for commerce. It would greatly, dramatically lower the cost for shipbuilding because you don't have to build large vessels that consume a lot of fossil fuels and diesel fuels. You can shrink down these vessels and make it more efficient, more environmentally sound, more sustainable, and sort of outsource the mundane, the boring, the dangerous activities to these robotic systems or autonomous systems. And once again, let the humans focus on the higher value missions that are necessary to sustain our way of living. He said that this would be the future of maritime shipping in his vision, just like we're going to see, autonomous self-driving vehicles for transporting goods and services on land. We know that that's being explored right now with some of the Tesla trucks and these other sort of 18-wheelers that are being sort of driven by AI systems because they don't require resting. They can transport 24 hours a day without the need to pull over to the side of the road to recuperate. And so that actually is a major productivity gain is what we're seeing that would be of impact to the industry as a whole and really lower the cost for goods and services overall.
Absolutely. I mean, I see another movie or book about this coming up. All right, that's absolutely, it's fascinating to even hear about this. The Mayflower is currently in port in England, planning in European voyage to Rotterdam in early spring 2022, actually this year, and transatlantic voyage in the second quarter. How can we follow its travels?
Sure, there's a website. It's a really, really dynamic site. I thought it was very, very helpful. It's MAS 400, Mike Alpha Sierra 400.com. There you actually have dashboards. You can see the status of all the critical systems on board. The cameras, there's 8 or 10 cameras on board. It's an AI-driven electro-optical and IR sensor. So those are basically for nighttime and daytime viewing. It's usually broadcasting 24/7, usually when it's operational underway. So you can literally be like you're on the Mayflower as it transits and see everything around it. And it's in near real time, just about. There is a little bit of latency because sometimes when you're transiting away from anything, you might see a little delay, but the buffer is pretty strong. And I think you'll have a good experience when they take a look at it. But that's one great place to see the status of Mayflower, the sea state, the condition of the ship as a whole, and then also the data that's collecting. What is the data that's collecting? So that'll be of interest to scientists and researchers out there.
I can't wait to get to really get access to it myself. My last question to you, Tony, what is the name? Have you given a name to this AI captain? It cannot be Watson everything, right?
That's the $1 million question, and we're open for a suggestion. So if anyone has a great suggestion, please, we're willing to take any and all recommendations. Captain Spice could be a good one.
Yeah.
We can try Captain Kirk from Star Trek. There's no shortage of creative ideas, but at this point, we are still looking for a representative name.
That's awesome. Thank you so much for sharing your insights with us today, Tony. And here are my key takeaways for on the implication of the Mayflower autonomous ship today. The number one is really marine research furthers understanding of the oceans and climate change, and really essentially to drive sustainability. Number two is the computer analysis at the edge can be applied to manufacturing and industry innovation. Number three, the MAS technology had direct relevance to improve efficiency of shipping industry and related automotive autonomous vehicles. Lastly, enterprises will have the potentials to leverage MAS design for ultimate use to improve customer experiences. I hope that accurately capture our conversation today.
Very well. Said it very well eloquently. Nice job.
Thank you. And for the audience here today, if you missed the first episode about Mayflower autonomous ship, please check that out. And then stay hungry, stay bold, and stay grateful.